Lesson 3.7, Determinants and Cramer's Rule. All this matrix stuff that we've been learning has to have some purpose, so today we're going to be doing a few applications. And we'll investigate solving systems of equations and finding the area of a triangle when we only know the coordinates of its vertices. To do these, we need to know about the determinant. The determinant is a number associated with square matrices. Different matrices can have the same determinant, symbolized by DET for determinant or absolute value bars around the matrix. The vertical lines, absolute value marks around a matrix mean determinant. So, to find the determinant of a 2 by 2 matrix, multiply along the down diagonal and subtract the product of the up diagonal. For example, multiply the downward diagonal minus the upward diagonal. So it'll be 2 times 4. Right here, 2 times 4 minus the upward diagonal, 3 times -1. So that gives you 8 plus 3 is 11. So the determinant of this matrix is 11. What's that mean? Well, nothing by itself, but it will be useful to do other things. This year you're going to learn a shortcut way for finding the determinant of a 3 by 3 matrix. You take the first 2 columns and you copy it behind the matrix, then do the products of the down diagonals and the products of the up diagonals. The down ones get added together, the up ones get subtracted. For example, take the first 2 columns and copy them behind the matrix. Then we have the downward diagonals, 1 times 5 times 9, 2 times 6 times 7, 3 times 4 times 8. Notice the downward diagonals are added together. Then we have the upward diagonals. Notice the upward diagonals are going to be subtracted. So an upward diagonal, 7 times 5 times 3. Then 8 times 6 times 1. And 9 times 4 times 2. And again, down diagonals are added, ups are subtracted. Alright, then do the simplifying. 1 times 5 times 9 is 45. 2 times 6 times 7 is 84. It's 96. It's 105. It's 48. It's 72. And when you combine all those together, you get 0, which is a fine answer. The area of a triangle can be found with this determinant. The x's and the y's are the coordinates of the vertices of the triangle, and the plus and minus is there just to make it positive. So from the determinant you could get a negative number, so then you'd use the minus to make it positive. Or if the determinant gave you a positive number, you'd use the plus to keep it positive. The area needs to be positive. They don't use absolute value because the determinant sign looks like an absolute value. So let's find the area of a triangle with these vertices. So we're going to take our formula and we're going to fill in the x and y's with our points. Need to find the determinant, so I'm going to copy the first 2 columns. These first 2 columns copied over here. And then we need the down diagonals. First down diagonal, 2 times 1 times 1, plus the next one, 4 times 1 times 2, plus the next one, 1 times 5 times -2. Then you have the up diagonals here. So it's minus 2 times 1 times 1. Minus negative 2 times 1 times 2. Minus 1 times 5 times 4, because they're up diagonals. And it's still multiplied by a half because the area is 1/2 the determinant. Simplify it together. That's 2, that's 8, that's negative 10, that's 2, it's negative 4, it's 20. All that together gives us negative 18. Multiply it by a half, you get negative 9. The area has to be positive. So let's say the area is 9. The other application is solving systems of equations. Cramers Rule is one way to solve a system of equation using determinants of matrices. So make sure your equations are in standard form, and then you make a matrix out of the coefficients. For 2 by 2, this would be our equations in standard form. The coefficients are A, B, C, and D. Notice the A, B, C, and D are the bottoms. The tops, the numerators, for the x column is replaced by the constants, the E and the F. For the y column is replaced with the constants. The other column is the same as below. The other column is the same as below. The column you are solving for, so here we wanted to know x, that's changed. Everything else is the same above and below. Here's the y. So the y column got changed. Everything else here is the same as below. So here's the system, and we're going to solve using Cramer's rule. The coefficients are 2, 1, 3, and negative 2. So we'll write those as the bottom when we solve for it. So here's Cramer's rule. Again, the bottom part is the determinant of a matrix made by all the coefficients. That's what's going to be on the bottom. The tops are the same as the bottom, just the column you're solving for is replaced by the constants. Start by finding x. The coefficients went down there. Coefficients from here are on the bottom. And the x column was replaced by the constants. The constants are 1 and negative 23, so I put those in the x column. The y column is the same as below. Find the determinants. So it's the downward diagonal, 1 times negative 2, minus the upward diagonal, negative 23 times 1. On the bottom, it's the downward, 2 times negative 2, minus the upward, 3 times 1. Simplify those. The top becomes 21, the bottom's negative 7. Divide x is negative 3. Find the y. The bottom is still the coefficients. Oh, we've already done this calculation. As we go through, we'll see the bottom becomes negative 7 because it's the same as down here. The top, the y column is the constants now. The x column is the same as below. So the y, we're trying to find the y. We use that. Downward diagonals minus upward diagonals to get your determinants. The 2 times negative 23 minus 3 times 1. On the bottom, 2 times negative 2 minus 3 times 1. Work those out. Top becomes negative 49. The bottom, see, it's negative 7 because it's the same as in the x. Technically, we only had to calculate it the first time. When you divide, you get 7. So our answer is negative 3, 7. If we're doing a 3 by 3 system, it's the same idea. The denominator, the bottom of the fraction, is the determinant of the coefficient matrix. The numerator is the same as the denominator, only the column you're solving for is replaced with the constants. If you're looking for x, the first column will be the constants. If you're looking for y, the second column will be the constants. Everything else is the same as below. Here's an example. The denominator are all the constants from our system up here, and the top is the same as the bottom except the x column. The x column here are these constants. Copy the first two columns over in order to find our determinant. We have all the downward diagonals, all the upward diagonals. So it's negative 4 times 4 times 5 on the top, negative 1 times negative 5 times 9, 6 times negative 7 times negative 2. Then we have upward diagonal, so we subtract, so it's minus 9 times 4 times 6, minus negative 2 times negative 5 times negative 4, minus 5 times negative 7 times negative. The bottom is determinant would be 2 times 4 times 5, negative 1, negative 5, negative 4, plus 6 times negative 2. Then we're going up, so it's minus negative 4 times 4 times 6, minus negative 2 times negative 5 times 2, minus 5 times 6 times negative 1. Work those out. Do the multiplication. Do the adding and subtracting. Notice the bottom became 54. So when we do the y and the z, you'll also notice the denominator is 54. Okay, same problem. Now we're looking for y. The denominator is still the coefficients, as we found and when we did x, it equals 54. So we know it'll be 54. The numerator is the same as the denominator, except for now the y column is the coefficients. Sorry, not the coefficients, the constants. The y column is the constants. Copy over the first two columns and find your determinants. So we need all the diagonals. So on the top we have 2 times negative 7 times 5 plus negative 4 times 5 times negative 4 plus 6 times 6 times 9. Now the upwards, minus negative 4 times negative 7 times 6 minus 9 times negative 5 times 2 minus 5 times 6 times negative 4. And you do the same thing on the bottom, but we've already calculated it and found that it was 54. Do the multiplying, adding and subtracting. Look, the denominator is still 54. Divide and you get 4. Now let's find z. So you can see the bottom is still all the coefficients. The top is the same, except for my z column is now the constants. Find the determinants by copying over the first two columns. Again, we don't really need to do the bottom because we found when we did the x that it was 54. And it's not going to change. Need our diagonals to find our determinants. So we have downward diagonal on top, 2 times 4 times 9, plus negative 1 times negative 7 times negative 4, plus negative 4 times 6 times negative 2, minus the upwards, so negative 4 times 4 times negative 4, minus negative 2 times negative 7 times 2, minus 9 times 6 times negative 1. And the bottom is 54 because we found that with the x. Do the multiplication. Add, subtract. You'll see, oh look, the bottom is still 54. Gives you 1. So our answer is x, y, and z, -3, 4, and 1. And that's all for today.